Another kind of straight line related question we might get is something that asks us to calculate areas. And there isn't really any new content in this, but it is putting together lots of the things we've been doing recently in a much more fully featured question. So here's an example of the sort of thing that you might get. The points A and B have coordinates -4, 6 and 8, 3 respectively. The line L1 passes through A and B. The line L2 has equation x minus 2y plus 4 is 0. The point of intersection of L1 and L2 is C. The line L3 passes through C. It is perpendicular to L1. Find the area enclosed by the lines L2, L3 and the coordinate axes. Now questions like this are quite difficult to do if you don't have a picture, an idea of what's going on. So let's draw one. Maybe you'll have one given to you in the question, maybe it'll be nice and accurately drawn, but usually it doesn't matter if it's accurately drawn, it's just so that you can see the ideas. So here are the points A and B that were given to us in the question. We're told that L1 is a line that goes through those 2 points. L2 is a line whose equation we are given. There's L2. We're told that the point of intersection of those 2 lines is C. Then we're told that the line L3 goes through C and is perpendicular to L1. And finally we're asked to find the area enclosed by lines L2, L3 and the coordinate axes. That is this area. The way we're going to do this is to find a slightly different area. If we find the area of this polygon, you can see it's the area we want and an extra little triangle which we'll need to get rid of. How would we find the areas of those polygons? If we could find the coordinates where L2 intersects the y-axis, L3 intercepts the x-axis, and also this point here, which is directly below C, so knowing the coordinates of C would help, then we could do everything. So how are we going to do that? First of all, we will need to know where C is, and C is the intersection of L1 and L2. We've got an equation for L2, but we don't have an equation for L1. So the first thing we should do is work out that line's equation. What we do know about L1 are the coordinates of 2 points on it. To work out the equation of a straight line, if you know 2 points, we'll also need to know a gradient, and then we can use a gradient in any one of those points. So, gradient of line L1, let's call that M1. We know that you work out a gradient by doing the change in the y-coordinates over the change in the x-coordinates. So in this case, that would be 6 subtract 3 divided by -4 subtract 8, which is 3 divided by -12. So the gradient is -1/4. Now we'll need to know the equation of the line. So using the idea of y minus y1 is equal to m into x minus x1. Which point shall we use? Of course it doesn't matter, we'll get the same answer, but I'm going to use the 8, 3 simply because they're both positive, makes it a bit nicer to write down. Y subtract 3 is -1/4 into x subtract 8. Now why did I get the equation of this line? I did it because I wanted to find where it intersects L2. Written like this, it's going to be a bit tricky to do that. So let's tidy it up a little bit. Let's multiply through both sides by 4. 4y subtract 12 is, if I multiply this by 4 it takes that out, but I've got a -1 times all of this, so if I expand the bracket I'll get -x plus 8, and let's really tidy it up so that everything's on one side. If I add an x to both sides, I'll have x plus 4y. I'll need to subtract an 8 from both sides. Subtract 20 is 0. Let me call that equation 1. It is the equation of L1. I also know the equation of L2. That is x subtract 2y plus 4 is 0. Let's call that equation 2. Now, if I need to find the point of intersection, I need to solve these simultaneously. So let's subtract one from the other. If I do equation 1, subtract equation 2, I get x subtract x, that's gone away. I get 4y subtract -2y, so I get 6y. I get -20, subtract 4, subtract 24, and 0 subtract 0 is 0. So therefore 6y is 24, and so y is 4. What's the x coordinate? Well, I could use either of the equations I've just done. I'm going to use equation 2. You get the same answer from either. Equation 2 tells me that x subtract 2 lots of y, and y I've just worked out is 4, plus 4 is 0. In other words, x subtract 8 and then plus 4, so that's x subtract 4 is 0. That tells me that x is also 4. So what have we learnt? We have learned that the point C has an x-coordinate of 4 and a y-coordinate of 4. So coming back to our picture, C is 4, 4. That's quite convenient because one of the points that we wanted to know was this point directly below C, and we can now see that the coordinates of that point are 4, 0. There's another point that we could find out from the information we've got, which is this point where y2 intersects the y-axis. To find that point, we'll have to take the equation of L2, which was x subtract 2y plus 4 is 0, and we'll have to see what happens when x is 0. If x is 0 in that line, that means that negative 2y plus 4 is 0, which means that 2y is 4, which means that y is 2, so the point we're interested there is 0, 2. And there we are. So we're getting there now. The only remaining point we need to know is this one where L3 intersects the x-axis, but that's not going to be any good if we do not know what the equation of L3 is. Well, what do we know about L3? It passes through C and it's perpendicular to L1. Can we work out its gradient? Yes, we can. We saw earlier on that the gradient of L1 was negative a quarter, and we want to find the gradient of the line perpendicular to it, the gradient of L3, so let's call that gradient M3. How do you find a perpendicular gradient? You need to do negative 1 divided by the original gradient. So in this case we need negative 1 divided by negative a quarter. Always horrible to divide by fractions, much nicer to multiply by the same fraction turned over. So in this case we can see the gradient of L3 is going to be 4. We also know that L3 passes through the point C, which is 4, 4. So the equation of L3 is y minus 4 is equal to 4 for the gradient, lots of x minus 4. Gosh, lots of 4's here. And what do we need to know this for? We need to know where this line intersects the x-axis. If it intersects the x-axis, that is where y is 0. And if y is 0 in this equation, we have that negative 4 is 4 lots of x minus 4. Dividing through by 4, we have that negative 1 is x minus 4. Adding a 4 to both sides, we have that x is 3. So the point we are interested in then is 3, 0. So there is our point, and we now know it to be 3, 0. Let's zoom in just on the shapes that we want. We now need to find the area, firstly, of the large trapezium. And we know that that's got a width of 4. This side's got a height of 4. This side has got a height of 2. So the area of that shape is, you have to add together the length of the parallel sides and divide by 2, multiply by the width of the base. If you don't remember the formula for the area of a trapezium, you could work it out much more easily by thinking of it as a rectangle and a triangle on top. But if you do remember it, that saves you a bit of time. 2 plus 4 is 6, divided by 2 is 3, multiplied by 4 is 12. that we also need to work out the area of this triangle. The base has got a length of 1, it's got a height of 4. So therefore this has got an area of a half times 1 times 4, which is 2. And so therefore the required area is 12 subtract 2, which is 10. And we have now found just the area that we required. In questions like this, there are very often a large number of ways of arriving at a final answer. I've seen one mark scheme that I think had 8 different suggestions for how the question could be marked. It doesn't matter which strategy you use, try and find the one that's the most straightforward for you.